Okay, we can start now. Good evening, good afternoon, everyone. Welcome to the fourth day of the Science Week. This week has been organized around the National Science Day by the Academy Trust, Indian Academy of Sciences, and Seed to Sapling Education based out of Bangalore. As part of this event, we have already had 3 live sessions on maths and science, which you can watch on this YouTube channel if you have missed them. Today we have a session on the joy of learning science in classrooms, which will be led by Dr. Pankaj Jain, who is the co-founder of Seed to Sapling Education. Pankaj is a lifelong learner and explorer, and along his journey, he has obtained a PhD in molecular biophysics from the Indian Institute of Science. He's an educator and has been actively involved in the field of school education since the past several years, which includes founding and leading S2S. He is a member of the National Focus Group on Holistic, Joyful, and Engaging Curriculum and Pedagogy, and the Karnataka State Focus Group on Science Education. Through his work, he aims to bring the joy of learning to the classrooms and create a stress-free environment in schools. For today's session, we will be needing certain materials, and these materials are listed in the description for the video. So if you don't have them, you can get them through the session. And I hope you enjoy the session. Over to you, Pankaj.
Thank you, Chintan. So nice to see teachers between us today. And we will have a very exploratory session. So please feel free to just play like kids. But at the end of it, so while you are doing all the exploration, the idea is we be aware of what we are doing, how we are doing it. So we will discuss the pedagogical aspects also of what we have been doing over the next couple of minutes, so that later on we will have a nice reflective interactive discussion based on what we have done in the first part. So I guess you have these materials ready. Now the main thing which is required is just a piece of paper, which I guess all of you will have easily available near you, a scissor if possible, and pen or pencil, that is also good to have. And if you can have some of these things, again, none of these are compulsory material, so any of these things if you have around you, that is good enough. Don't worry if you don't have these materials. So say a paper clip or a cello tape, glue, thread, cotton. So these are all optional things. If you have, good enough. So if you don't have, that's okay. Okay, so let's take this first question. What is science? Okay, so I thought doing this question in the Padlet, but let's do it here in the chat box itself. Let's do this question in the chat box. What is science? Or okay, I'll just share this link of the Padlet if some of you want to do it in the Padlet. If you open this Padlet, you can just directly pitch in your response. It will open something like this. You can click this +1, and you can type whatever you want to say about science. So it's easy to use. If you find it difficult, you can use the chat feature in Zoom and in YouTube. So don't worry if you can't open the Padlet thing. So, okay, so we get the responses, interesting responses. Science is an experimental subject. Anything that develops scientific attitude is science. Okay, any other responses? What is science? Science is a fact to explore. Okay, science is a fact to explore. Nice. Any other thoughts? What is science? Science is the knowledge of everything. Okay, so there is science is the knowledge. It is experimental subject. Learning by doing, so you do things. It's a fact. Study of how the world works. Okay, the study of how the world works. Interesting. Any other thoughts? What is science? Science is the knowledge of everything. Science is the knowledge. It is experimental subject. Learning by doing, so you do things. It's a fact. Right. Okay. So all right. So we are getting a lot of interesting responses about science. Science is life right from living to non-living things. Is a life right from living to non-living things. Okay. So let's keep these definitions of science, whatever we think of. Uh, okay, so science is when you question how, when, why, what. Is knowledge to understand better. Okay. So lot of interesting responses. Now let's go to something else now. Okay, so just keep this idea of thought, science, okay, with us while we are exploring things in this session. We will revisit this question later on. So it's a beautiful gift to humanity. Who gave this gift to humanity? Knowledge to understand better, right? So let's move on from here. I have a small video with you. Okay, now the task is simple. The task is as simple as just asking questions. Okay, so I'll play this video with you, and all you have to do is to just keep asking questions, as many questions as you can ask. Okay, so let's not stop asking questions. You can just ask these questions over here. So I'll just create a column, another column in Padlet. If possible, just try to answer all these things in Padlet. See, we have a lot of interesting things over here. Science is intellectual and practical activity. Okay, so we will go through all these responses later on. Now, based on this video, let's ask as many questions, whatever comes to our mind. It can be observations also, but even if there are observations, just see if you can convert these observations. In example, I see so and so things, and I wonder, okay, I wonder how, what, why. Okay, so let's see this video. Yeah, there's no audio. Don't worry about the audio. Just see something, some phenomena over here. Okay, so any questions that come to your mind, please feel free to ask those questions over here. Okay, whatever questions coming to your mind, whatever questions, don't stop from asking. Don't judge each other's question if you are seeing these questions on YouTube or on Zoom. So don't stop. Yes, based on this video, whatever questions come to your mind based on this video. Okay, why the leaves are falling? Okay, so you have observed. Is it a leaf? Is it a leaf? Okay, how do leaves fall off? Who has seen the wind? Okay, let me play this video again. Okay. Who has seen the wind? All right, interesting. Yes, any other question? How do objects fall? Nice, nice, nice. Okay. How do objects fall? Is it talking of how we spread knowledge like dispersal? Okay. Okay. Let me show this, whatever this is, whatever this object is. Let me show you how it, just see how it is falling down. Let me show you a slow motion video of the same thing. Right. How do light objects fall? Which type of tree was it? Change of leaf color. Was it even a leaf or was it something else? Why the leaves fall on ground and not going up? Wow. Wow, wow, wow. Why sky is blue and clouds white? Wow, nice. Right. So how do how do color of flowers? Okay, I guess there is something incomplete. If you can just complete that question. Okay, and is it the mulberry seeds falling like a helicopter, dispersal of seeds? Is it seed or leaf? That is one of the question. Dry leaves fly. Why not fresh leaves? Okay, so interesting phenomena of dispersal. So there are a lot of interesting questions which are coming in over here. Okay, so now my next task is this. If we have this phenomena which we are seeing now, and we have asked so many questions: is it a leaf, is it a pod, is it a feather, is it a seed, how it's falling down, why is it not going up, why do light objects spin while falling? So many questions are there, so the next task is simple. How do we find out the answers to these questions? Okay, so how do we find out the answers to these questions? Can you just write down whatever, you take any question that you have? Okay, you can write it in the Padlet or in the chat, whatever option you find comfortable. So you have your own questions. Now my next question is, how do you find out the answers to your own questions? So the question is, how do you, okay, can you just design something? If you are saying investigation, we start exploring, whatever it is. So how do you want to do it? For your own question, take your own question, for example. Take your own question, for example. Now, how do you want to find out the answer for your own question? So like somebody asked the question, why light objects spin while falling? For example, somebody asked this question, right? Now, how do we find out the answer to this question? You can take your own question. There's no need to take each other's question. You can take your own question. Okay, so somebody is saying we ask more and more questions. So will asking more and more questions give us the answer? Collecting information and investigation. Can you just do it? For example, take your question. Tell me specifically, how do you find out the answer for your question? So can you just write down what was your question and how do you now go about finding out the answer for your question? So you can do it in the Padlet, so it will be easier in the Padlet. Like say you can just write down your question and then say that I will find out the answer to my question in so and so and so and so way. So you can just do it in, can you just design some experiments? So using data for observation, using it over and over again, to gain a final most probable answer. Okay, all right. So can you just specifically tell me? Yes, please do it in the chat if Padlet is not working. Can you specifically take any one question and try to answer that specific question? Take any one question of your choice and do it. Give me, how do you find out the answer to that one specific question? By putting us in the situation, the question which we are thinking. Okay. All right. So prediction hypothesis. Why does light object spin? Now I will take one variable in my experiment each time and see how it affects the results. Very nice. Very nice. Excellent. So somebody is probably asking the question, why does light object spin or not? So take one variable at a time, each time, and see how it affects the results. So probably you will increase the weight of the or the mass of the object every time. Nice. So we already have some experiment designs. Scattering of light after understanding the basics. Okay. So you will do some experiments around the scattering of light. So can you just think of more such ways and means? Take any specific question and see how do you go about answering that question. Right. So we are finding, we found answers by experimenting. Who has seen the wing? Okay. Fine. All right. So now let's take the other thing. Let's go to the next task. Okay. So we have asked our own questions and started designing something to explore our own questions. Okay. So now let's go to the next task. So the first thing is like, it is not a leaf or it is not some feather. It is actually a seed. Okay. So why do plants have such seeds? Why do plants have such seeds? Any guesses? Why will plants have such seeds? A quick response for this question. What advantage will the plants get from having this kind of seeds? So some of them are, just make a guess. If you don't know, it's okay. There's nothing like right or wrong. Okay, so easy for seed dispersal. Okay, great. Now let's do something interesting. So it is basically for seed dispersal so that it is falling down slowly. It will take the seed far and wide. Right. Now the idea is this. Can you create something like this seed using simple piece of paper or any other material that you have with you right now? Okay. So that it doesn't fall down directly. Like our seed, which was not falling down directly, it was spinning. It was there was a lot of drag. It was coming down very slowly. Right. So yes, Neha. So it is easy for seed dispersal and it helps the trees to go into multiple distances. So it can travel far and wide and there can be another tree at that distance, right? So now how do we model this seed using the materials that are easily available with us? So you have a lot of materials with you, right? Paper you all have. You have a lot of other materials also around you right now. Can you just, if you are on Zoom, can you just turn on your video? If you can just turn on your video, if you have created something of paper or any other thing, and just show how is it working. Yeah, on Zoom, can you just show how is it working so that it is not falling down? Okay. Vasudha has made a nice fish kind of thing. You can see, right? Vasudha, can you just, I'll come to the other people also. Can you just make it fall and let's see how it works? I guess you will have to remove the virtual background, otherwise it's not visible. Can you just show how it falls down? Nice. So the fish was taking turns. Very nice, interesting. Any other design? I guess Shanti has another design. So wait, I'll just remove the previous. Okay, so we have some more design over here. It is just falling down. Can you do something so that it doesn't fall down straight? Anybody else wants to show your design? You can just raise your hand. I will spotlight your video. Right. So can you do something with this paper and see that it is not falling down directly? Can you create some kind of drag in this piece of paper, or you can do anything you want? So we already have one design. Somebody tried, we can make aeroplane. Okay, nice. We can make aeroplane. Even on YouTube, if you can just write down what is your design. If you can just write down what kind of design you made. Yeah, if anybody wants to join Zoom, you can join Zoom from YouTube. Somebody will share the details. Okay, so some designs are working, some are not working. Can you try some more designs? Everybody can try some designs. Just from a piece of paper, try to make it fall from a height and see if it is falling down or it is not falling down smoothly. So can you do something so that it doesn't fall down freely? Rather, it will just create some sort of drag from a piece of paper. We can tie the piece of paper upward side. Okay, made a toffee. Okay, can make aeroplane, tying the paper. Somebody made a fish. Anybody else? Any other design from YouTube? Anybody wants to share any other design you have made? Yes, Advai, can you show your design? Okay, so in the teacher session, we have some student, but he has an interesting design. Yes, is it falling down or is it not falling down? It is some kind of flying. Good, a budding teacher we have. It's falling down. Can you make some design which is creating a drag petal shape? Okay, we can make a parachute, we can make a petal shape. Can you just try all these kind of designs and see how these designs are working? Lot of designs people are trying. Okay, Padmavati is showing me something. Yes, yes. Can you just uh, release this paper? Yes, ma'am. Is it falling down or is it uh, gliding, or there is some sort of drag created? Can you just show us once again? Right. So we have seen lot of designs done by many people. Now some of these designs have worked and some of these designs have not worked. So what do we do? There are some designs which have worked. There are some designs which have not worked. Small strip of paper with both ends taped together. Okay, so making kind of a cylinder kind of thing from a paper is what somebody is saying. Light objects fall because of the gravity of Earth, or that always light object fall hold the air. Okay, floats due to aerodynamically. Even so somebody is saying even a thin strip of paper will float. Okay, try it with tissue paper. With tissue paper, it's working. With normal paper, some things are working. With tissue paper, something else are working. All right. Okay. So we have a lot of designs coming from you all. Now, okay. Somebody wants to show me again. Okay. Go ahead. Can you show your design, Advai? Use angled paper on each side. Yes. Can you just release this? Can you just release this and see? Okay. You have kind of throwing it. Okay. Okay. Monica is showing something. Yes, release it. Ah, so it is not falling down, it is going in some other direction. Nice. Okay, so we have lot of designs, angled paper, just a small strip of paper. Somebody says, somebody is folding, joining the end, somebody is making a fish, somebody is doing some other kind of thing, somebody is making a plane. So a lot of designs have already come from you all. Now let's go ahead with something else and see. I'll just now show you to make some design. Okay, I will ask, give you some instructions. There will be a design which is there. You can all make that same design. Okay, so basically all we have to do is to take a piece of paper, a strip of paper, and fold it in this way. Okay, so taking this strip of paper, all right, and have these cuts. I will just make one and show, and then you can make the exact same thing again. Okay, so let's do this. Okay, so it's just a single cut over here. All right, a simple cut, 1/3 of it, 1/3 cut over here and 1/3 of cut over here. So these many cuts. Okay, and this gets folded on this side, this gets folded on the other side, right? So we have this small little helicopter over here. And let's release this. Okay, let's release this and see how it comes down. Okay, so I will just try to release it from some distance. See, it is rotating like a helicopter, just like that seed. Can you all make this? Is it possible to make this? A simple design. I'll just share my screen so that we can all see it. Just taking a strip of paper, cut on these two edges and make a fold so that you will get this base and the wings of the helicopter, the two wings of the helicopter. Just try to climb on a stool or something and try to release it from a height. See if it is coming down or not coming down. Or is it moving like a helicopter? Is it working? You will have to. Okay, I'll show a video. I'll just show a video to see how it works. Okay, how to make it work. Okay, so once you have your strip, wait, let's start here. Yeah, you have this strip, fold it into two. So cut on those three lines. Yeah, everybody can just do some till this point and then we will just make those cuts. Yes. So Sridevi says there is a particular type of seed which works on the same lines. When it falls to the ground from the tree, we can even see that the outer pod is twisted. Very nice, interesting observation, Sridevi. The outer pod is twisted. So let's make these cuts. Yes, maple seed, precisely. So teachers, especially all the teachers out there, just see what we are doing, how we are doing. We are certainly doing something, but that is interesting. All of you are finding it interesting and you are making your paper copters and all. But just also keep in mind the pedagogy that we are using at each of the step. Okay, if you, these are all optional things. You can use these things as optional. Otherwise, we will see, this is how it comes down. See, this is how it has come down. If somebody is on a terrace and wants to push it down or something, you can do all those kind of things, right? So everybody have their maple seeds ready, or this helicopter paper helicopter ready with you. Can you just play around with it for a while? Yes, you can just play around with it, whatever way you want. Just see that whether this helicopter seed is working or not working. Right. Works perfectly, works perfectly. Okay, let me show you my thing also, if in case somebody is still not able to get one. I will just try to stand on a height. You can, it comes down nicely, slowly it comes down. Right? All right. So everybody have their seeds ready. This is ready, then we move on from here. Everybody is ready with this step. That we will. Sridevi, just hold on with your question. Just hold on with your question. Okay. So Sridevi has a nice question. I'll not read out that question, but we will just wait for a while. Everybody is ready with this? Everybody is ready with this? Just give me a thumbs up or tell me yes, yes. Everybody is ready with this? All right. So now my question is, how does this work? How does this work? How does this work? Why is it not falling down? Why is it not falling down? Why is it rotating? Due to the blades. Okay, somebody says it is due to the blades. Any other reason? Why is it not falling down? Why is it rotating? Air pressure, wings, blades, drag of air. We're getting lots of responses for the reason. Okay, due to the aerodynamic design. Okay, because it is very light, but just the paper was also very light because of this structure. But what is this structure exactly doing so that it is not falling down? Air is also a factor. Okay, balancing, shape. All right, area is increased. Whoever wants to inform anything, you can just write it in the chat box. It's because of the slits which are opposite direction and air. Okay, flapping like bird wings. Nice, nice, nice. So there are already a lot of reasons which you have given, but we don't know what is the exact reason, right? We are still not sure what is the exact reason. Okay, so this helicopter-like object spins and generates lift due to the streamlined body, reducing the effect of gravity and fluid friction, and it has some drag. Okay, so lot of reasons. Right, wind plays a role, supports the movement of air. So a lot of reasons are coming in. Now comes the most important part from here for the helicopter thing, and then we will go to the other important part in some way. How do we go ahead from here? What do we do now? We have got this thing. We know fairly, okay, this may be the reason, this may be the reason, but what should we do now? Based on this helicopter, do you have anything in mind? You would like to do this or that, or you would like to know more about it, or what, how to do that? Any of those kind of questions coming to your mind? Playing around with this further. Anybody has any other things in mind with this helicopter? You have any specific questions which you would like to answer from this helicopter? Yes, anything that changing angles to see what happens. Okay, okay. So Arno already says that, oh, so we are already getting a lot of things. So what will happen if we change the angles and see what happens? Okay, so changing the direction. So if the angle changes, will it change the direction? Or the number of changing directions, number of blades. Somebody says how to make it fall slower. Similarly, how can we make it fall faster? Or suppose if I have 4 wings instead of 2 wings. Okay, so 4 wings instead of 2 wings. Okay, any other things you would like to do something? Any other thing you would like to? What will happen if we rotate and make it fall? Okay, if we rotate and make it fall, okay. So lot of things. Can more changes be made to change the rotation? Okay. How to change speed, how to change direction. Mine only goes in one direction. Excellent, excellent, excellent. Can we make it with plastic? Very nice. Can we make it with plastic? Okay. So somebody wants to see the seed of falling. Advay, you can just go on the YouTube and you can go behind the session and you can see the previous part of the session. Okay. When we rotate, the airplane will fall. Okay. It's a statement. Any further thing you would want to do from this? How can we make it to glide and not fall down. Oh, wow, wow, wow. So Venkat says, how can we make it glide instead of making it fall down? So broadly, if we categorize most of the things that you are doing into two parts, one can be you explore. Okay, so what if I change the length? Somebody said, what if I have 4 wings instead of 2 wings? Somebody said, what if I change the direction of the blades? Right? So there were many of those explorations that many people wanted to do. And there are many of these other things that how do I stop the rotation or how do I change the direction? Um, there were many such questions. Wait, so see, can you just put those things into explorations and let's categorize them into exploration? Okay, so I will just go one by one and you just tell me whether it's an exploration or an investigation. Okay, so what will happen if we change the angles? Like that becomes an exploration. What will happen? Let me just change the angles or change the number of blades. But then somebody says that how do we make it fall slower? How do we make it fall slower? So this becomes an investigation. So you will have some reason. Okay, maybe if I do this, it will fall slower. So you will have some initial reason and start doing it, right? So there are many of these exploratory things which you have mentioned, and there are many investigative questions. So how do I make it like that? What happens if I no, what happens? That will again become an exploration. Like what happens if the length of the rotor is smaller than the body? So can we just go ahead with these explorations of yours and whatever investigative questions you have, right? So how to make it fall slowly without rotating? Somebody has this question, how to make it fall slowly? So you can design your own investigations also. So I will do one thing. I will just create 2 columns over here in the Padlet because it will be easier. Many of you might want to share the photographs or the videos of these things working. So in the Padlet, I'm creating 2 columns, explorations, investigations. So explorations is like change of length, um, blade numbers, or any of these kind of explorations, right? Investigation is like how to make it fall slower or how to change the direction, right? So what will happen if I do this? That is all exploration. What will happen if I change the direction, I change the length, if I change the blade, if I change this, if I add something? But how to make it fall slower, how to change the direction? We are now talking about investigation. Then there may be multiple reasons, multiple ways to do it. Okay, so you can go to the Padlet. Now, if you are doing anything, you can describe your experiment over here. You can take photograph of your experiment by clicking on this camera icon and just say click the thing. So even people on YouTube, you are free to share your explorations and investigation. You just say save, it will come in the Padlet post. Okay, so you can share your photograph, you can share the video. All right, so all these options are possible in the Padlet. So I'll just show you how to take a video also. Just click on these 3 dots and see video recorder instead of camera. Camera is for photograph, video recorder is a video recorder. It may take some time initially to, you may have to give the permissions to take the photograph or the video. So all those things you do, and then you start recording whatever you want to show, that I changed this and this is what happens. I changed this, this is what happens. I had this question in mind initially, then I went about changing these things, and this is what I see. So you are free to share your investigations over there. Okay, so I will, can you just explore now freely? Just explore whatever way you want to explore. Feel free to do any explorations you want. Just share your exploration. Finally, whatever observations you get, that I tried this and this is how it worked, or this is what I was expecting, but it worked that way. So you can inform about your initial prediction also, and then how it actually worked. Play around with this and please share whatever you are observing. So will a plastic straw also work? Why not? Let's try it out. Let's see what happens with a plastic straw. Right? So feel free to do your explorations, your English. You are free to explore it in any which way. Please share whatever you are exploring. I tried with 4 wings, speed increased, I noted. Okay, nice. Okay. So somebody said, Shanti says, I tried with 4 wings and the speed increased. Arnav says, I tried to change the shape of the blades. I thought it would help change the direction it moves, but it fell faster as I decreased the surface area of the blade. So yes, you can play around with it further. You can play around with it in any which way. So already some of you have shared it on the chat. I'll just go to the Padlet. Okay, there are a couple of things on the Padlet, but make it one lighter. You please feel free to share whatever you are doing. That will be helpful for all of us to know what you are doing.
Yeah. Shanti, if you can also show how did you create 4 blades? Is there only one way to create those 4 blades, or can we create the blades in multiple ways? That may be another thing which can be done. So if you can quickly show how are you doing it, I think that would be helpful for us.
Yes, anybody else explore something interesting? Anything? Okay, I can see many of you are playing around with it. Please share whatever you are finding it out. Whether it is working, not working, we are not worried about the right thing or the wrong thing. We are just seeing how it works.
Yeah, we can see Shanti's model also. So she has created 4 blades, and the interesting aspect is that, like, how are the different ways we can bend those 4 blades? And if we are bending in different ways, then what kind of motion will it show? So that can be interesting aspect. Yeah, you can try it out different variation and see.
Well, so we have a paper copter with 4 blades here. Okay. On Padlet, somebody says that I tried to use smaller rotors than the body and it fell faster. So everybody is doing their own explorations. Change the angles. Yes, somebody trying to change the angle, and let's see what happens changing the angles. You can change angles. You can do many things. You can add some weight. Anybody adding some weight over here or here or here? We can add some weights. Let's see if it makes it better, or let's see how it changes. If we add something which is very heavy or not so heavy, we can add something. I added weight and it sank down. But how much weight do we add? Can we just tape it instead of adding a lot of weight? Maybe we can just put some cello tape or maybe a paper pin, a paper clip or something. Okay, it is just falling down. So adding a lot of weight, just make it fall down. If we tape it, it will float. Can you just try, Nitya? Can you just try with a tape? So maybe we can just add some weight over here, or over here, maybe we can add some, whatever. We can add some weight in the wings over here. Let's see what happens. Yes, Amulya. So shorter blades make it fall slower. Adding weight at the bottom makes it fall faster. Okay. As the number increase, the speed increase. Okay. Somebody is changing the angles. A couple of you are typing. So fine, we will just wait for some more time. Cloth clip. Okay, that is making it fall faster. So Advai, can you just turn on your video so that I can pin you if you want? Anybody else wants to show something interesting, please raise your hand or let me know in the chat box. I will spotlight you. Yes, Advait.
So I want to tell, I have got this butterfly shaped thing. So when I have released this, it's gliding.
Ah, nice. Very nice. Excellent. So we are having.
Show it one more time, please.
Advait, can you show it once again?
So it's very fast. So you can't see. Can I make a slow-mo and send it?
Sure.
Yeah.
So
Sure.
Where can I send?
You can share it in the Padlet. We will share the link.
So I know the link of Padlet, but how to send? Please tell again.
You just open a new post and there is a way to post a video over there. Okay. So Arnav says the higher the weight is, more the spin. Lower the weight is lesser the spin. Okay. So Suryan says, I tried with increase in weight length, so it falls lower. Okay. Wing length, not weight length. Sorry. So many of you are trying multiple different things. Arnav wants to show. Okay, Arnav, you want to show. So let's see. Yes, Arnav. Sorry, I will have to. Yes, Arnav.
Sir, I have made this flower.
Is it falling like a paper copter or just falling down? It's just falling down. Right. So just see the way these kind of things fall down. Now, can you just reason out why that one is just falling down and this one is getting a drag thing, so it doesn't fall down freely? So anyways, you can just think about it. Bhupendra says that I changed design. Actually, I forgot the way I created the previous one, but now new design help to increase drag and little bit it rotates. So it will be very interesting if all of you can share your design in the Padlet, or if you just raise your hand, I can ask you to show it right away. Monica, you want to show your design? Just a thin rectangular strip of paper, Nitya. Okay, so just a thin strip of paper. You don't need anything else. Just a strip of paper is what Nitya says. That's all you need. You don't need any of these fancy structures. Then all you need is just a strip of paper. So just a strip of paper itself is working. Let's try. Everybody, you can just try with this strip of paper itself. So it's floating quite well for Nitya. All right. So we have a lot of interesting things happening. I will do one thing now. For all the students out there, you are free to play around with it for the next 15 minutes, 20 minutes, or half an hour. If you want, you can put your comments in the chat box, but we will have more focused discussion with the teachers now. Okay. So we have done a lot of this playing around things with paper copter. Towards the end, at around 5:50 or so, we will come back to this paper copter. Okay. We will discuss all these other things that we are doing. So you are free to keep doing it. Okay. All the students who are there on YouTube and on some of you are there on Zoom also. So you're free to do that. But now we will focus the discussion slightly more for the teachers. Okay. So we will just start seeing what did we do till now. Okay. So we did.
Also, before we go to the discussion with teachers, there are many claims which we can see in the chat. So the students who are playing, if you can also counter something, like if someone said that by adding the weight, it is spinning more. Can you come up with an example where you are adding the weight, but it is not spinning more, it is spinning less? So if you can come up with those kind of examples, that would also be interesting.
Right. Nice. Interesting. So all the students out there, you are like free to explore. and while we have some discussions with our teachers today. Okay, so for teachers, see, we have done a couple of things today, right? So just a quick reflection. What did you like about this task? Very quickly. This is just a very quick thing. Uh, a very quick thing. What did you like about this task? Or if you did not like, you just feel free to tell, okay, this is what I did not like. All right. So experimentation, knowledge about gravity, interesting, hands-on experience. Any other got more knowledge, kept the students engaged, learning by doing, show the experiences. Okay, so we are getting a lot of thoughts from the teachers. Yeah, any other thoughts? What did you like about the session till now? Any other thoughts? Fun by playing, okay, interesting, like to show the experience. Science of airlifting, okay, right. Now let me, learning by doing, how to apply the scientific facts, great. So involving full calculation, okay, happy to play. Know more about the use of blade, rotation, gravity, brain enhancement. Okay, now let me ask you another very pointed question. So we had 3 tasks till now. So the first task, we started with asking very open-ended questions, where I did not tell you anything, just showed some video. You were observing that video and came up with your own questions, and some of you also came up with ways to answer those questions, or some of you generally told that we will answer these questions by some investigation, exploration, but there was nothing told from our side. So this was just like showed a video, right, in the first task. The second task, you all came up with different solutions to this modeling of this copper seed, maple seed, right? So you came up with your own ways, made something out of paper or cotton. So that was the second task. The third task was, we all made this design. So initially I gave the instructions, and then we played around with this design. So that was the third task, right? So I am writing down all these 3 tasks in this table. So the first task was like, you observe question after seeing the video. The second task was you modeled this paper copter using, this copter seed using paper. The third one was, we instructed something, showed you something, how to make this paper copter, and we all made this design of a paper copter. Okay, so how is this task, the third task, different from the first 2 tasks? I have created another column on the Padlet. If you can reflect based on all these 3 different activities, and see how these tasks are different from each other. We will have some discussion on these 3 tasks. How are and before that, if you can just share your thoughts, you can share your thoughts in the Padlet. Or you can share your thoughts in the chat box. Basically, the question is this: how is this task 3 different than the first 2 tasks? First task was openly asking any questions. You can come up with any question and any experiment of your choice. The second one was, a specific question was posed that, can you model this copper seed? And the third one was, we made a specific design of copper seed. So based on these 3 tasks, can you just reflect back? What did we do? How did we do? How were they similar or different from each other? Please share it in the chat box or the Padlet, preferably Padlet. Can you do this comparative analysis between the 3 tasks? So just when you are writing something, say that task 1 was this, task 2 was this, task 3 was this. So Jyoti, when you say own designing experience, can you just say which one was own designing experience? If you can just specifically reflect for each of the things. If you can specifically reflect for each of the things, like what did we learn specifically in each of these things? Task 1 was ideation, task 2 was creating, task 3 was designing. Wow, nice. Balan summarizes all these 3 tasks just in one word. Very nice. Okay, any other thoughts? Any other thoughts? How is task 3 different from task 1 and 2? How is task 3 different from task 1 and 2? Task 1 was observation task. Advai, please stop chatting. Task 1 was observation task, 2 was experimentation task, and the third one was applying. Okay. Right. So let's put down our thoughts. We recreated the copter seeds. Okay. Okay. Let's write down our thoughts specifically for each of the tasks. Okay. So I'll just exit. So task 1, many of you are saying, was about observation. So who asked the question in task 1? Who asked the question in task 1 initially? Who asked the question in task 1? Collecting. Okay, I'll just write down these thoughts. Okay, whatever is coming in the chat box, I'll just. Right. So task 1 is think and observe. Think and observe. Very nice. Observation task. Execute. Task 3 is specific. Somebody says task 3 is specific. Plan and design. Task 3 is specific. Okay. Creativity. Collecting data. Specific guidance. Okay. Application of concept. Okay. Application task. See, many of you are saying it's application of something. All right. Task 3 was guided to specific learning outcome. Capacity to observe it. I just put down these thoughts also coming from YouTube. So task 1 tested our observations, something which is already written. Task 2 was hands-on and application, that is also okay. Task 2 was also hands-on. So task 1, we did not go into the part where we have to start. Okay. So task 3 was guided to specific outcome. Okay. Guided to specific outcome also. All right. Any other thoughts? Any other thoughts about these 3 tasks? Observation, testing, experimenting. All right. So in first task, when you all observed and questioned, could we have pursued the experimentation part even over there? Was it possible? Just tell me a yes or no. In task 1, we did not pursue. I quickly came to the second task. But in task 1, because I wanted to come to this discussion, that was the reason. But otherwise in task 1, could we have designed our experiments and did some hands-on based on those questions that we each of us asked? No? So let me go to those questions which we asked in task 1. Okay, let's see those questions. Right, let's see some of those questions. Right? Why is only one leaf flying? Okay, or is it a leaf or is it a seed? Okay, or there was this another question like, does lighter thing always fly? So can we start asking these questions and then figure out a way to answer these questions even from task 1, or that is not possible? That is only questions. We cannot answer those questions.
There is also one question on why does light object spin when they fall?
Right.
So,
why does light object spin when something fall? So can we start answering those questions, like start designing some, like second thing, I asked you a question. Okay, so it's no, unless we have knowledge about the answer. So in second task, I asked you a question. Can you model a paper copter? So for that, was it possible to answer this question? I asked you a question specifically. So in second task, I gave you a question instead of the question coming for you. But so second task, to some extent, okay. So you can answer this question to some extent. Why only to some extent? What stops us to answer completely? Like modeling a copter. Some of you came up with this paper fish, right? Quickly, because we did not try it. So if we give enough time, can you try it and come up with some solution to that? Is it possible to try and after you think? Yes, after you think, correct. So it takes probably more time to think. Okay. What about this? You had a question. See, here I gave you a question, but here you all had a question. Now, based on our own question, is it possible to find some answers for our own question? In this case, the first case, where you... Okay, so we cannot be certain about outcomes unless we do the procedure first. No one knew what would happen if sodium was added in water till they practically did it. But who asked them to do it? Takes time and effort to conceptualize. Very nice. So this is a fair enough point. It takes time. Like say sodium and water. Nobody asked them to do it, but somebody did it, right, for the first time. So somebody might have just asked the question, okay, what if I add? Their curiosity asked them to do it. So now, if you are having some curiosity and starts asking question around that, will the student do it? Curiosity and questioning ability. Very nice. Very nice. So in the first one, you need more of this curiosity and questioning ability. But is it possible with our students? Are our students curious and can they ask questions or no? Others, what do you feel? Can our students ask questions? Okay, I'm getting mostly yes. Are our students curious? Yes or no? Yes. Okay. Now this is about curiosity, so they have to ask questions also. What about this, where we can still give a question? Provide situation to become curious. Very nice. So we need to provide a correct situation to become curious. Okay. Need to provide a right situation. Okay. That's a fair point. That's a very nice point. Provide a situation to make them curious. Very nice. Okay. When they relate to it, so they need to relate to it. Need to relate. Okay. Very nice. All right. So then what about this? We just ask a question. Can our students find out the answers? Some of you are already saying that it takes time to think, but otherwise, can they come up with these answers by themselves to an extent, or maybe with some guidance or some hints in between? Or can they come up with different kind of answers? See, because when we ask them to make a copter, see, today intentionally quickly rush through all the 3 activities, 15 minutes each maybe maximum. Okay, they can hypothesize, they can answer. Prior knowledge is essential for some of the things. Yes, prior knowledge is essential, but they have to think. So can our students think? Can our students think? Can they think? Discuss? Yes, discussion, thinking. So this needs more of discussion, definitely more time for discussion, thinking. Yes, everyone can. So somebody say, okay, a student is saying that, yes, I can think. So I know Advai is a student of, I guess, primary class. So yes, they can think. So this definitely need the right situation, right? More time to think. Yes, that is all fair enough. What about this? What about this? Where we give them a specific task, you do it in that way, that you make a paper copter. So right. So now this is Nitya, when you say this is where creativity comes in. So Nitya, this creativity, is it for task 1, task 2 or task 3? Nitya, whatever you are suggesting, is this for task 1, task 2 or task 3? It is for all. So in task 3, just imagine if we just stopped at making this paper copter. Today we went beyond that. Okay, today we went beyond that. But what if we stopped at making this paper copter, where everybody was happy to play around just with this paper copter, but we did not explore it further. We make this paper copter, somebody instructed us, and we make this paper copter, but no exploration beyond that. Will that also lead to creativity? We would be stuck, right? Yes, we would be stuck. If we don't give this creativity, there won't be any further innovation. See, if we do give time for exploration beyond this, then certainly yes. But what if we don't give time beyond this? Yes. In third comes more about curiosity in changing the normal thing. So we can change the normal thing and make it happen later, right? So otherwise it doesn't happen in the third one. So let's try to now summarize these things, whatever we have done, some of the points which we have already written down. So let's see what happens. Okay, so there are, takes time. I guess all these things which we have gone previously from the teachers, these are just like summary of all the points that we have got previously from the teachers. Okay, so let's see. This is not something that we have written. These are all things which have come from the teachers. So learner invents their own path of investigation. There are many questions and many paths, because initially it will lead to many questions. It may just become very vague also, or we may ask them to then select one specific question and select only that path. But at the same time, they have much more ownership, because they are coming up with these questions by themselves. It takes time. It certainly takes time. This also takes more time to think, but lesser time because the questioning time is lesser. Now this doesn't take much time. Okay, I'll come to this slide again. Now let's start filling this question. Well, this table now. In the first approach, who is asking the question? Let's take only this first now. Who is asking the question? We have two people. One is learner and one is facilitator. Okay, so just tell me, in this first case, who is asking the question, the learner or the teacher? Okay, I'm learner. Who is coming up with the procedure? If we had more time, maybe we would have taken one specific question and we would have strict to that question and spend more time on that. So if they are coming up with a question and then we ask them to, okay, how do you figure out that question? Yes, okay. So some of you are saying learner and some of you are saying both. With some discussion, so I'll just write down with some discussion, with some help. Who is coming up with the solutions? Okay, so who is finding out the solution finally? Again, a learner. In the second case, who is giving the question? Like I gave you this question that, can you model a paper copter? Who is giving this question? initially. In the second case, where there was a specific question asked that can you model a paper copter, right? So it becomes by the facilitator. But who is coming up with the procedure to find out the answer to that question? Okay, that is again by a learner. And who finds out the solution? All right. Now let's go to the third case where I gave you the initial design. I'm only talking about the first part, not the exploration part. Okay. So who gave the question? So both means the learner is involved and the facilitator is just facilitating. That is, I'm just writing learner over here. Okay. So in this case, the facilitator gave the question. Who gave the procedure? Who gave the procedure? Again, the facilitator. Who find out the answer, how it is working? Who find out the answer? Okay, so the answer still is found out by the learner beyond some, if we give them that opportunity. But what if we, even for this purpose, see, there are many times where we have seen, even including our science journals, right? So this is same thing. So question is asked by learner in the open inquiry. There is a name, technical name to it, which is called an open inquiry, where learner is having the entire authority. Now with our constraints, I don't know if that is possible all the time, but maybe sometimes, who knows, but at least guided, where we give only the question, let them come up with their own creative solutions, creative procedures also, right? Because in the third case, many times if we tell them something, there is only one right answer. There is only this one right answer, which we have already told them. And there are many times we tell them the answer also. We demonstrate, see, this is how the thing becomes and this is how it falls down. This is what you follow the instructions in science journal, follow the task A, B, C, D, E. So our science journal are which category? Open inquiry, guided inquiry, structured inquiry, and confirmation inquiry. Whatever we do in our science journals, is the question, procedure, solution given or not given? Which type of inquiry is our science journals? Can you just try to sink in a lot of these things that we are discussing suddenly and apply it for our science journals, or more lot of textbook activities which are there? Are they open, where everything is left to the learner? Are they guided inquiry, where only the question is provided, but the answer is figured out by the procedure is also figured out by the learner, and the answer is also figured out by the learner? Okay. Or these are structured, where we only give the question and procedure, solution still is found out by the learner? Or it is confirmational, we just give away everything, they just have to probably do it and verify it, confirm whether it is working or not working. So is it only for verification purpose? So what about our science journal, science experiments that we do in the lab? Which type of inquiry would you place them? Open, guided, structured, or confirmational? Teachers? Okay, so we are getting solutions of specific problems. Shanti says open, guided, structure. Can you just elaborate, ma'am? What do you mean? Anybody wants to speak out something, please raise your hand and we will just unmute you, ask you to unmute. There is a raise hand feature. So only for the teachers, not the students. So where the learner is allowed to think on all aspects of the question, and yes, procedure is already given in how to go about it. So if the procedure is already given, already these two categories are ruled out. We are only left with the structured or the confirmational inquiry. Okay, Harsh, I guess somebody raised their hand. Can you please raise your hand again? I miss seeing that. If anybody wants to. Right. So now the task is, see, there are many activities in the textbooks which are structured activity. Can we try to not give away the procedure still. Like say, I could have shown you this before itself instead of asking you to model the maple seed, right? I could have just asked you to follow my instructions and make this maple seed. Or you can you come up with your own specific design and you use your own creativity. You come up with your own procedure. Can you design an experiment to test whether this is working that way or this way? Okay, so this structured or conformational inquiry, can we just go to one level higher in our classroom or in our science labs? Is it possible? Like we at least remove the procedure part, or we at least don't tell them the solution. Let them figure out the solution by themselves. Is it possible to, wherever there is a conformational inquiry, can we at least go to the structured inquiry? Wherever there is a structured inquiry, can we at least go to the guided inquiry where we don't give away the procedure? It may take time. It may not be possible all the time, but at least maybe a couple of times in a year. Is it possible? How many times it is possible to do a guided inquiry in the classroom in a year? In a year where we are taking, say, 10 to 12 chapters or 15 chapters and almost 40 different concepts or 50 different concepts. How many times we can give them only the question, but don't even give them a way to answer that question? Let them figure out the way also to answer that question. At least once for every chapter? Yes. Is it possible at least once for every chapter? I don't know. I'm just leaving it open to you. See, it is very challenging, right? See, it is very challenging. It takes time to design an experiment. It takes time to think. We are all agreeing that our students can think, but this is still challenging. So why are we okay with these challenges? Why are you all still saying yes? This is challenging, right? Why are we saying that we will take up this challenge? I want to know the reason. Why are you saying yes? You are saying our students can think, we will make them think, but it takes time. It is so much of mental burden on them. But it is possible. But why should we do it? Okay, not for all subjects. Let's talk about science for now. In chemistry lab, we should provide, otherwise it may be harmful. True. So wherever there is safety aspect, yes, certainly we cannot, to know their capability, okay. But we can still do it wherever it is possible, yes, because we can give that platform for their capabilities. Any other reason? Why should we do this? Why should we do this? One is to give platform to their thinking abilities. Can do it in art. Okay, we should give them in physics. We should not give them in chemistry. That is good thing. To get a personal experience, okay. To get a person, yes, there is time constraints. That is what we discussed, that there is time constraints. But can we address this still little bit, or we just go ahead with the flow where the science is then just taken as a piece of knowledge that we have to transmit, or it's a process that we take as a journey? So this is something up to you, us. So this is to get a personal experience to the learning by doing, okay. Is it only by doing, or is it also by thinking? See, experimentation to verify is one thing, but one is they don't even know what may be the reason. It will take too much time. Yes. So now what do? It certainly takes too much time. So should we do it or should we not do it? Let's come back to this basic question. Should we do it or can we do it or no? We have to address this problem, right? It takes time. Certainly it will take time because thinking will take time. See, if I were to just follow what you are, like to make this paper copter, it took only 5 minutes. But to come up with your own design and improve it further, it takes time, right? Everybody is thinking in their own creative way. It takes time. Instead of 5 minutes, it might have actually taken 15 minutes then. Instead of 5 minutes, it may take away the entire period. So now what do we do it? Should we do it or should we not do it? Okay, let me open this floor. Okay, so anybody wants to speak, please feel free to unmute and speak. Should we make it happen or should we not make it happen? It certainly takes time. Why should we do it? Let's have some discussion. We generally call our program dialogue on learning. Let's have some dialogue on this because this is very important. Unless we address our challenges, we may not feel the need to do it. So let's address. why should we do it and why should we not do it, or these are the reason for not doing it, but if these reasons are addressed to an extent, I am still open to do it. So why should we do it? Let's take these points first. Why should we do it? Anybody wants to speak up? Why should we do it?
We should do it because we have already perked the curiosity of our students.
Okay, ma'am, very nice point. But because it takes time, right? So then how can we do it if it takes so much time?
It can be structured in a way, and moreover, I think you should do a prototype yourself first before actually presenting it in the class and having all sorts of problems that come your way. But definitely after bringing up the curiosity of a child to a certain level, it's not fair on them to just suspend them there or say, okay, let's do this sometime later, or lose interest in it. That's going to set a precedence, and I think it's going to disappoint the children a lot. That's my opinion. I'm just, because I always go ahead with it. Somehow or the other, we always see the end of it. So it's work for me. I thought I'll just share that.
Great, great. Nice thoughts. Anybody else? Nice thoughts by Kavita. Anybody else want to share your thought? Yes.
Sir, it does not start from the seniors, because as the juniors, from the students from the lower level, as they start from the environmental science, and they slowly from the beginning, we should give them this challenges from the beginning, and then only this all structure inquiry and all these inquiry helps. And then they started experimenting, they start doing, investigating all these things, then only it comes. We cannot immediately ask them, do this. As a teacher, we cannot ask.
Excellent point, ma'am. So it's very important, right, that we give them this exposure of thinking. See, otherwise we are actually conditioning them to just follow the instructions, versus we are conditioning them to think independently, think creatively, think critically, see whether it is going this way or not going this way. And one very nice point which Rashmi is making, to create interest among students. So it is certainly challenging, but is it also joyful for a learner or no? Is it joyful for a learner? I want to know your opinion. It is challenging, right? It is actually challenging to make them think and design. This may actually be very challenging for a child, but will it be joyful also at the same time? What do you all think? Yes or no? Will it be joyful, or it will be like very taxing, very stressful? Yes, Kavita, you want to...
I feel joy is, joy and disappointment is part of the whole thing, isn't it? I mean, we got to let them go through it.
Right.
By exploring it by themselves, there is always that aha moment at the end of it all. They
may fail. They may also fail in the process. They may not get it. So what do we do?
So it's like those 10 different ways you shouldn't do it is what the teacher should go over and explain to those people. I mean, to the students who didn't get it, So, I think it's a journey of discovery, science. It's a journey more than seeking joy always. I mean, it's not going to turn out right the first time, is my opinion.
Right. Nice, wonderful. So, see, this becomes very important. So the reason why I asked this question, what is science? It becomes very important. What do we understand by science? In fact, some of you may have read the blog that I wrote recently and got published. So if we only think of science as something which is a body of knowledge or understanding of the nature or universe that we have to share it with our students, that is one aspect of science. But the other aspect is, how do we understand the universe? How do we go about exploring any new phenomena which I encounter every passing day? So one is understanding, the other thing is, how do we understand it, right? So with that, I just want to ask your opinion again before we try to conclude today's session. But what is your understanding of science now after the session? You wrote down your understanding of science earlier, but I want to know your understanding. What is science for you now after this session? At least, is it changed your definition of science, little bit, no, yes. What is science for you now? If I were to ask you again this question, what is science? Let's take this question again in the Padlet. What is science part 2? What is science part 2? Okay. Or you can put it in the chat box. Feel free to put it in the chat box. Okay. It's there in the Padlet also, but feel free to put it in the chat box. Yeah. What is science? Knowledge, understanding, exploration, journey, product, process, all those things. Because unless our own belief system of this, what do we think of science, that may get addressed. Otherwise, it will be like, we feel it is more important for the students to know things, we will make them know things. We feel it is important for them to explore, know how to find out more about things, we will give them that kind of platform. Or it is also about this fun part in this journey, the journey along with that joy aspect in the journey. So, right. So with that, let me quickly tell you about this Science Week in a minute or so. Science is journey of thinking, experimenting, and getting the outcomes, exploring new things on the way. Very nice. Acquiring knowledge and its application, building a scientific temper. See, that is again very, very important, building this scientific temper, which we have not discussed much yet. So asking questions, we don't have to be like just accepting the authority. We have to question people. We have to question things, being wondering about things. So that time scientific temperament becomes even more important, right? So now in this Science Week, I'll just quickly, just give me half a minute. I'll quickly tell you about these upcoming events. There's a session, similar session for math teachers day after tomorrow. On Saturday, we have a very interesting talk by Professor Rohini Godbole, who is a Padma Shri and an authority in the field of particle physics. And on Sunday, we have a session for students, an exploratory session on math. So this is the upcoming program as part of Science Week. Then we have a 12-week workshop for teachers. A 12-week workshop for teachers on this joy of learning. We will discuss different strategies. How do we address all these problems and everything? So we will share the details with you. This is a certificate course by the Academy Trust of Indian Academy of Sciences. And there will be separate course for science teachers and math teachers. Whoever is interested in that, we will circulate a form later on. There is no registration fee, but there will be some selection for this program. So we will share the details, and this program will run for 12 weeks through the summer vacation, a once in a week kind of session. And we have a very exciting contest coming up, again, to give importance to this process of science instead of the product. So instead of having a quiz contest, we have a question contest. Instead of having a project which is again focusing on the product of science, we thought we will give importance to the process of science, and the process starts at observation and question. So again, it is separate for students and for teachers. See, students ask questions, observe things, but we as teachers, we are also learners independently. So we have a category for teachers also. Just ask a question, and what made you to ask that question. Again, the details will be shared after the Science Week, and you can participate in this question contest also. I will strongly encourage all of you to participate in this question contest. Basically just about asking one question, and how do we find out the answer for this one question. It's as simple as that. A very simple contest of questioning. So that is about for today's session. Now I want you to, before leaving, I want you to share your reflections from today's session. And Vaishnavi is going to share a form with you for today's session. And there is this Mentimeter thing. If you can tell one word about this. Vaishnavi, over to you. Can you just take this up? Vaishnavi? Yeah, we will have the discussion session. Just give like 1 or 2 minutes. We share the form and this one word feedback or reflections from today's session. And then we go to this more discussion. I know that we need a lot more discussion. So we are still here. We will continue with this discussion.
Good evening, everyone. The link to share your experience from today's session in one word has been shared in the chat box. And we will share the feedback form as well, a more detailed feedback form.
So Vaishnavi, can we just share this Mentimeter thing and ask them how this works, Mentimeter?
Yeah. So, just a second. Would you like me to share my screen?
Yes, sure.
So when you click on the link that's shared in the chat box, you will get a chance to share your experiences in just one word. We'll get a very interesting output describing all your collective thoughts and experiences from this whole session. And we'll be happy to share that with you as well. So request all of you to kindly fill up your experiences over here in the first link. The second link is a much more detailed feedback form, and we look forward to seeing your responses on that one as well.
So I've just shared this Mentimeter link. If you can just put in that one word in that Mentimeter thing. So what is that one word from today's feedback? More than feedback, let's make it a reflective thing in that one word. Okay. So what is that one word to describe today's session, the learnings from today's session? And then please fill in this reflection and feedback form. It is not just the feedback of today's session, but it is more about reflection on what do we learn, what do we take back from this session of almost 1.5 hours. So, and what all things can go in the classroom also later on. So it is more about our own reflections. So please fill in this reflection form also, which is shared in the chat box. I have just shared that again on YouTube and on Zoom. So Vaishnavi or Chintan, if you can just pin that feedback form on the...
Pinning it, we are pinning it right now.
Yeah. So yeah, now it's open for discussion. So please feel free to pitch in. Somebody had raised your hand. So any thoughts, any question, anything you want further discussion, feel free to initiate the discussion. Nitya, you had raised your hand, so.
Yes, sir. I had a small question that for the Quest Fairs, there was the form where we had registered before for the science week. So there was a small question that, are you curious about asking questions? I had actually said no there. So now is there a chance to come back again to the question?
It will be open for everybody, so you still have a chance to. Yeah, that's open still. It's not.
Okay, sir. Thank you so much.
Sure. Okay. So please fill in this feedback form and your reflections in that. So, yeah.
Also, so small question, another question. Sir, on the National Science Day, there was a session at 6 p.m. Where a professor came from IIT Madras. So I had some questions regarding that. So how can I, how he said that we can also send him questions after the session too. So is there a chance to maybe send him some questions? How can I do it?
You can send a question to this mail ID from which you are getting the mails for all these sessions, right? Shubhankar is there. Yes, Shubhankar.
Yes. Nitya, you can email your question to that wherever you got the invite from. It's a trust email ID, trust@ias.ac.in.
Okay, sir. Sure.
You got your initial invite there, right? So email the question there, and I'll try to get it answered by, if it's a question for the professor, Professor Pradeep, who had spoken.
Yes, sir.
Then I'll try to get the answer from him. So you just send me the question and I'll try to do that for you.
Sir, actually it was in the Science Week group. I had actually picked it up from the Science Week group.
That doesn't matter. So you got an invite from do you have that email?
Sir, there was another email today. It was called the Academy Trust. There was an email ID like that.
Yes. So send a reply to that. Send your question as a reply to that mail.
Sure, sir. Sure.
Yeah. Okay.
Thank you. Thank you so much.
Well,
Right. Any other thoughts to discuss? So Shubhankar is the Executive Secretary of the Indian Academy of Sciences.
yeah. Hello all, and I'm so happy to see so much interest, and it was really an engaging thing. And this is what the whole idea behind having this science month was about. It's actually more than a week. It's going to go on for several weeks. So I'm so happy to see that that you all have responded so fantastically.
Right. Thank you to the Academy for this wonderful thing to organize for students, for teachers, for the general science enthusiasts across the country. So Vaishnavi, can you just share this Mentimeter thing? I'm actually very curious to know.
Absolutely, so am I.
What is that one word thing people took back from today's session? So.
I think a lot of people are still filling up, so maybe I'll give it 30 seconds more.
Yeah, any question any teacher wants to ask, any thoughts you want to share, any discussion you want to initiate?
I would also request Nitya to send his an intro about which class, which school.
Sure, sir. Definitely. Definitely.
Yeah?
Sure.
Okay, so that's how this. Right. I hope it was a good session, but also more importantly, it has something for us to take back for our classroom so that we at least think more about it, or a little bit, okay, maybe I can just give this much break, maybe 5 seconds, 10 seconds, half a minute, 1 minute, 5 minutes for our students to think more, design their own things, giving the platform for their own independent creative thinking. So, very helpful. Right. So yes, this session we will try to conduct every year, if not throughout the year, but at least every year once or once in a while we would definitely try to have such sessions. Yes or no?
Thank you all for sharing your very nice responses. I hope you can see the screen share so that you can all see each other's responses. Are you able to see my screen, Pankaj?
Yeah. Sure. I'm just waiting if there is anybody has any question or any thought to share, because we have, see, these are like real challenges, the time constraints in the classroom. So typically when we work with the teachers in whatever schools, the idea is at least can we give them some opportunity for one topic every chapter, or for even that one chapter, one period, maybe 5 minutes can be spent for each chapter extra, or 10 minutes or half an hour, wherever possible. For lower classes, there may be more opportunity. See, as someone very nicely pointed out today, it has to start from the lower classes. So it brings the onus more on the lower classes so that we prepare our students who are independent thinkers, who can design their own experiments, who can give reasons for what they think, what they predict, what they observe, so that they are more prepared for the higher classes. And hopefully with the coming of NEP, we will have similar kind of, the curriculum will demand such pedagogy and the assessments later on. So this is what we all hope for. Right. All right. So with that, if there is no further discussion, let's conclude today's session. Thank you everyone for joining. It was a wonderful session. I really enjoyed with you all. A lot of discussions happened. I hope we will have more such sessions in the future so that we can take up more of these kind of topics. And do join for this workshop, 12-week workshop for the teachers. We will circulate the form soon. There will be selection, but if there is more interest, we will see if we can accommodate or maybe have another session later on or something. So feel free to sign up for that 12-week that workshop, certification workshop, any which ways. We would love to have you all for that workshop again, and see you soon.